Hello, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is day 6 of Algorithms in Swift. Day 6. For today's problem, we're going to be focusing on lossless data compression and run length encoding. If those terms went over your head, not to fear. We've all used lossless data compression. If you ever use a computer, if you use PNG image files, if you use a GIF file, if you ever had to compress something in zip or gzip, zip and gzip, both of those or all of those use lossless data compression. It's compacting data in a consolidated way without losing the data. Okay, this alternative would be lossy data compression. Run length encoding is taking repeated consecutive sequences of data and storing them as a single unit of data. Okay, so we're going to turn this into this. Okay, so our algorithm is going to be focusing on strings, and we're going to literally use run length encoding to compact a string that is so expressive in value. And it's better if I show you than I tell you. So let's get straight to it. Write a function that accepts a string as input, then returns how often each letter is repeated in a single run, taking case into account. This approach is used in a simple lossless compression technique called run length encoding, like I described to you guys earlier. And if you guys want to understand more information about lossless compression or run length encoding, I encourage you guys to look it up on the internet. You'd be surprised at what kind of interesting things you actually use with lossless compression. But so here are some sample examples. It's you see the string AA, BB, CC. That's returned A2, B2, and C2 because A appears twice, B appears twice, C appears twice in a single line. What makes this problem deceptively tricky is that you have to add the number of times the integer appears in a single run after the letter. So you have to add the integer directly after the letter and represent the number. So that's challenging because if we just wanted to find out how many times a character appeared in a string, we could easily find that out through various ways. For loops, replacing occurrences of many different ways. However, this is asking how many times a letter appears consecutively and then adding the integer representation of how many times that letter appears consecutively directly after the number. But that becomes challenging to do because that's very explicitly representing run length encoding. But fear no more, we have a solution. So we're going to start right here. Oops, capital letters. Let's start right here. Func. It makes it a bit bigger for you guys to see. Func run length encoding. Run length. We just call it run length string. Passing string. Return a string. And we're going to create a var of an empty string. We're going to call it run length string. It's going to be empty. Then we're going to create a counter. So basically what we're going to do here is we're going to do a fast enumeration. And on our first index, our first run, we're going to ask if we're on our first run, pretty much. And we're going to add the first letter here to the run length string, okay? Then we're going to create an if statement asking throughout the for loop if the last letter of the string, the run length string, is equal to, or is not equal to, in this case, the letter that we're currently on. If it's not equal to that, we're going to add an integer to the string, and we'll add a number to the string. We'll convert it to a number, and then we'll convert it to a string, and then we're going to append the letter that we're currently on, to the string. And if that's not true, then we're just going to keep adding to the counter until we get to a contradiction in the string. So if that makes no sense, or if that is confusing or over your head, we're going to solve this right now so we can be clear. Okay, so here we go. For index letter in the string, if index equals, fast enumeration. Okay. If index equals 0, meaning we're on our first run, then we're going to append. We're going to append our current letter. Okay. Then we're going to write an if-else statement here. If run length string, in fact, I'll do it. This will be clearer. If letter is not equal to run length string dot last, then we're going to append the counter and convert the counter integer into a string, and then we're going to append the current letter to the string. Okay. Else, this is not true. We're just going to run length string dot append. Sorry. Oh no, we're not appending. I'm sorry. Getting too fast. Counter plus equals 1. Okay. Then after the for loop, if we get to the end of the string, of course, and we don't find a contradiction here, then we'll never append the counter at the end of the string. So what we could do is, at the end of the for loop, just append whatever number counter is at. So whatever number we're at on the counter, we'll append that to the end of the string. Let's go right into the string. Okay, and then we're just going to return this run length string. Okay, so this should work. I'm pretty confident about this, but let the computer tell us. Hopefully it doesn't ruin my confidence for the day. Let's see. Oh, it's ugly. Okay. Oh, sorry. I know what we did wrong. We have to make this 1 so that it could, so as soon as a letter, oops, sorry, wrong sticker. So as soon as a letter appears, we need to make it 1. We need to, so if a letter appears like 3 times here, I'm glad we found this mistake because I can use this as a teaching moment. If a letter appears 3 times and then we get to a contradiction of B, we need to reduce the value of the counter back to 1. Otherwise, it's going to keep counting up and up and up. It's never going to go down. So we need to reset it so that it can start up again. And it starts at 1 because we're on a new letter, and that letter appears 1 time. Okay, so B should have 1 behind it, and this A should have 3 behind it. It should be accurate this time. So let's go through it. Cool. Okay, that looks like what we should have. It is A3, B, A3, B1, A3, B1, A3, A3, B1, A3, B1, A3. Okay, let's do double A because this should be A2, A2, lowercase to, well, let me show you guys. Lowercase a, capital A2, lowercase A2, lowercase A2, capital A2, lowercase A2. Because we're taking case into account. So that should be correct as well. Boom. And then let's just do one more. Let's do the ABCs. Boom. Okay. So this works. I think this is a very straightforward approach, brute force approach, but it works. And I think that it is much more effective than using the if-let optional approach, which I've seen, which is it's a very good approach as well, but it's a bit tricky if you have to continue unwrapping optionals and doing optional checking. That's pretty tricky, but this solution works. Let me know what you guys think of the solution, and if you have any suggested approaches or any different ways of solving this problem. I think this is a rather tricky problem, and I think this would be a good test if you want in for interviews. And I've seen this come up in interviews before, so be prepared for this. Thanks again, guys. Have a great day.